Today we will talk about what's clean architecture and how to use it in vibe coding environment. Welcome to this deep dive where we're tackling clean architecture. Ever felt like your code base is, a tangled mess where just one small change can set off unexpected chaos everywhere?
Oh, definitely. Happens all the time.
Well, clean architecture kind of offers a blueprint to organize your code. The idea is to keep it flexible, maintainable, by clearly separating your core business logic from all the infrastructure stuff.
Right, the plumbing, basically.
Exactly. So our mission today is to really get under the hood of the main ideas, weigh the pros and cons, the real world ones, and see how these concepts could, broadly apply to software development. Even if we're not diving specifically into the Vibe environment itself today, understanding these principles gives you a solid foundation, really, no matter where you're coding.
Absolutely. And to help us do that, we pulled together some really insightful sources. We'll be looking at articles from DEV Community by Yuki Onishi, digging into some key ideas from Uncle Bob's Clean Code blog.
Uncle Bob, always essential.
Indeed. And exploring a WAFI solutions piece that connects domain-driven design, DDD, with clean architecture quite nicely. Plus, we even looked into a Reddit discussion to get some, real developer opinions.
Oh, cool. So what a good mix.
Yeah, it's a fantastic mix, I think. Gives us everything from the basics, the what and why, to the practical how, and even some of those common developer debates around it.
Okay, great. So let's jump right in. What is clean architecture at its core? Like, what problem is it actually trying to solve?
Well, at its heart, clean architecture is really all about creating a system that's robust, adaptable, by clearly separating concerns. Think of it like organizing your software into distinct layers.
The layers.
Yeah, layers. And each layer has a very specific job and, crucially, doesn't need to know too much about what the other layers are up to. The key principle that makes this work is what's called the dependency rule.
The dependency rule. That sounds like the core concept here.
It really is.
Yeah.
The dependency rule basically says that the inner layers of your application, that's your core business logic, they should be completely unaware of the outer layers. Things like your UI or your database. All the source code dependencies, they should always point inwards towards that core.
Inward. Okay.
Imagine an onion, maybe, or as Uncle Bob often shows it, concentric circles. The innermost circles hold your really critical business rules. Those are the entities. These are the fundamental business concepts that would exist no matter what kind of app you are building.
Right.
As you move outwards, you hit the use cases. These define the specific ways a user can interact with your application based on those core business rules.
Okay, so let's say our entity is a customer with name and address, that kind of thing. A use case might be create new customer, which applies certain business rules, maybe validation, to that customer entity.
Exactly. Perfect example. The entities define what a customer is, fundamentally. The use case defines how you might interact with it, like creating one, with all the relevant business logic involved.
Got it. So as we move even further out, what's next?
Next up, we find the interface adapters layer. This is where things like your controllers, presenters, gateways live. Their main job is to translate data.
Translate?
Yeah, they take the data formats that are convenient for those inner layers, the entities and use cases, and they convert them into formats needed by the outside world, like a database or a web interface or whatever. Think of them like translators at a conference, taking one language, converting it precisely for someone else. So data coming in from your website gets translated here before hitting the use cases.
And data going back out gets formatted too.
Exactly. It gets formatted for the web view or API response, whatever it might be.
Right. So they're like this crucial hub connecting the core logic to all the external systems.
Yeah.
And the very, very outermost circle, what's that?
That's the frameworks and drivers layer. This is where you find the really concrete stuff, the technology-specific things. Your specific database system, like PostgreSQL or maybe MongoDB, your web frameworks React, Django, whatever UI toolkits, external APIs you talk to. The really critical thing here is you want to keep as little business logic as possible in this layer. It should mostly be just the glue code connecting these external tools back to the cleaner, more abstract inner layers.
Interesting. So it's not like a super rigid 4-layer cake then. You could have maybe more layers or fewer, depending on the project.
Precisely. Yeah, Uncle Bob's 4 circles are a great way to visualize the principle, but the core idea is always that dependency rule. You might end up with, 3 layers, maybe 5, depending on complexity. But that fundamental rule dependencies always point inwards that stays constant. The deeper you go into the architecture, the more abstract your code is, and the more insulated it is from changes happening out in those more volatile text-specific outer layers.
Okay, that makes a lot of sense. So why bother with all this structuring, all these layers? What are the actual tangible benefits you get from adopting clean architecture in, a real project?
Yeah, the DEV community article by Yuki and Ishii lays out several key advantages really well. Uh, First and foremost is improved maintainability.
Maintainability, okay.
Because you've created these clear boundaries and separated your core business logic from the infrastructure, changes in one area are just far less likely to cause unexpected ripples or problems elsewhere. Think about it. Say you need to swap out your database. In a more tangled system, that could mean touching code all over the place.
Oh, yeah, nightmare scenario.
With clean architecture, because your business logic doesn't even know how data is stored, you're mostly just changing things in that outer database layer, maybe the adapter that connects to it. That's a huge win for making upgrades or modifications safer and easier.
That really does sound like a lifesaver, especially with older systems or when requirements are changing fast. What else?
Easier testing is another big one.
Right.
Because your business logic is isolated in those inner layers, you can write unit tests that focus just on that logic. You don't have to worry about setting up databases or UIs or other external stuff.
Oh, okay.
This makes your tests much simpler to write, way faster to run, and ultimately more reliable for catching bugs early on.
Yeah.
Imagine testing your core application rules without even needing a database connection.
Oh, wow. So you can really be surgical with the testing, just hitting the pure logic. Yeah, that sounds like a huge plus for code quality.
Absolutely. And that isolation, it also leads to increased flexibility and reusability. Because the modules are independent and loosely coupled, you might be able to reuse components or features elsewhere, maybe even in different projects. And like we touched on with maintainability, if you decide later to switch tech stacks, different framework, different database, but it's much less scary because your core logic isn't welded to the old technology.
So picking up a new framework, it doesn't mean a total rewrite.
Pretty much. Yuki and Ishii's article also points out independence from technical details. By using interfaces and abstraction, you effectively decouple your business logic from the concrete implementations, the specific database, the specific UI framework, the specific API client.
Right.
This abstraction means you can swap those underlying technologies without messing with the core application logic.
And the last one the DEV community article mentioned was clear structure. I can definitely see how having these well-defined layers and responsibilities would make it easier for, say, new developers joining a team to actually understand how the project fits together.
Exactly right. It gives a much clearer mental map of how the different parts interact, makes the code base easier to navigate, understand, contribute to, which is obviously huge for team productivity and the long-term health of the project.
Okay, the benefits sound pretty compelling, I have to say. But, like with any architectural approach, there's got to be trade-offs, right? What are the potential downsides Yuki mentions?
Yeah, absolutely. The first one is increased initial development cost. Implementing clean architecture usually needs a fair bit of upfront design work. You got to spend time defining the layers, carefully designing the interfaces between them, really thinking through that separation. For very small projects, or maybe short-term ones where speed is the absolute top priority, that initial overhead might feel like, well, like it's not worth the effort.
Yeah, I can picture that. For like a quick prototype or a small internal tool, you might feel like you're building this huge, complex structure when maybe just a simple shed would do the job.
That leads right into the next potential drawback:
Increased.
complexity. Just having multiple layers and the interfaces needed to connect them can increase the overall complexity of the project, at least in terms of the number of files and maybe the initial learning curve.
Right.
For smaller apps, this added complexity might feel like overkill. It could potentially slow things down a bit as you're always jumping between different layers.
So more moving parts, basically, even if they are neatly organized.
Correct. And there's also a steep learning curve. For developers who are new to these kinds of architectural patterns, concepts like abstraction and dependency inversion can be challenging to really grasp and implement correctly at first. It often takes a bit of experience and a kind of shift in thinking about how you structure code.
Yeah, not something a junior dev might just pick up instantly.
Not necessarily, no. You need to understand the why behind it all. Another potential issue is the risk of over-engineering.
Ah, always a danger.
Right. Strictly applying clean architecture to every single project, no matter the size or complexity, can definitely lead to unnecessary abstractions and layers that don't actually provide much benefit and might even make the code harder to manage in the long run. You don't want layers just for the sake of having layers.
Right. Got to be pragmatic. Choose the right tool for the job.
Exactly. And finally, the article mentions potential performance overhead. Introducing multiple layers and interfaces can sometimes add a tiny bit of performance cost because of the extra indirection. Usually it's negligible in most apps, but
But if you're building something super performance critical,
exactly, if every millisecond counts, that's something you'd need to carefully consider and probably measure through performance testing.
okay, so it's definitely a balancing act. You get these big long-term advantages, but there might be some upfront costs and complexities to think about. Now, the WAFI Solutions article brings domain-driven design, or DDD, into the picture.
hmm
How does that fit in with clean architecture? Are they competing ideas, or do they work together somehow?
That's a really great connection to make. DDD, domain-driven design, is fundamentally an approach that emphasizes deeply understanding and accurately modeling the problem domain, the real-world business processes, the rules, the concepts your software deals with.
Right, the business itself.
Exactly. And the Vive Solutions article explains how DDD and clean architecture are actually very complementary. They work together beautifully. DDD gives you the guidance on what your software should be about focusing on that core business logic, creating a shared understanding of the domain, while clean architecture provides the structure, the principles for organizing that logic and keeping it separate from infrastructure concerns.
Ah, okay. So DDD helps you define the stuff in those inner layers, the entities and use cases, but maybe in a more robust, meaningful way.
Precisely. The article points out that DDD itself often has a layered structure, and you can see really clear parallels with clean architecture. For instance, the DDD domain layer that contains the core use case independent business logic, the entities that lines up almost perfectly with the entities layer in clean architecture.
Okay.
Similarly, the application layer in DDD, which orchestrates the use cases using that domain logic, maps really well to the use cases layer in clean architecture.
Okay. Yeah, I'm starting to see how they fit snugly together. What about the other DDD layers?
DDD also usually includes a presentation layer for the UI and an infrastructure layer that handles things like database interactions, messaging, external system integrations, basically supporting the other layers.
And those map too.
Yep. Those layers in DDD have pretty clear counterparts in Clean Architecture's interface adapters layer, especially for the presentation parts, and the frameworks and drivers layer for all that infrastructure stuff.
That makes the relationship much clearer now. It's like DDD provides the content, the subject matter, and clean architecture gives you the framework for organizing and presenting it cleanly. And the WAFI article mentions specific DDD concepts. How do those fit in?
Right. So core DDD concepts like entities, those objects with unique identities representing key things in your domain, and value objects, immutable objects defined just by their attributes, no unique ID. Both of those live firmly within the domain layer in a clean architecture setup.
Makes sense.
Aggregates and aggregate roots, which are these clusters of related objects treated as a single unit for consistency, they're also key parts of that domain layer.
And what about things like repositories and domain services? Where do they live?
So repositories in DDD are abstractions for accessing data, right? Typically, they're interfaces, the definition of how you interact with them, live within the inner layers, the domain and application layers. But the actual implementations, the code that talks to a specific database that lived out in the infrastructure layer.
Ah, so that keeps the dependency rule intact again.
Exactly. The inner layers depend on the abstract interface, not the concrete database code. Domain services, which are stateless operations embodying business logic that doesn't really belong to a specific entity or value object, they also belong in the domain layer. And domain events, which signal important things happening in the domain, they can originate in the inner layers but might be handled by outer layers, crossing boundaries in a controlled way.
Wow. Okay. So DDD gives you the language and the patterns for thinking about the business, modeling it, and clean architecture gives you the structural discipline to keep that business logic pure, focused, and separate from all the technical noise around it.
Exactly. It's a really powerful combination, especially for building complex, long-lasting, domain-focused systems.
Now, Uncle Bob's blog post gets into the real nuts and bolts of how you actually cross those boundaries between layers while still following that crucial dependency rule. How does that work? It sounds tricky.
Yeah, it's a critical piece of the puzzle.
Yeah.
As we said, the dependency rule means inner layers can't know about outer layers,
Yeah.
but obviously parts of the app need to talk to each other. Uncle Bob explains we do this using interfaces and something called the dependency inversion principle.
Dependency inversion principle. Okay, that sounds important. Break it down.
It's fundamental. Let's use a common example. A use case, which is inner layer, needs to present some data to the user via a presenter, which is outer layer.
Right.
The use case can't directly call the presenter because that would be an inner to outer dependency breaks the rule. So the solution is to define an interface, sometimes called an output port, within the inner use cases layer. This interface just defines the methods the use case needs to call to get data presented, like present customer data.
Okay, so the use case defines a contract for what it needs done.
Exactly. Then the presenter, out in the interface adapters layer, implements that interface. It provides the actual code for, say, formatting the data and displaying it on the screen.
Ah, so the inner, more stable layer defines the need, and the outer, more changeable layer provides the implementation. That flips the dependency around.
Precisely. The flow of control might go from, say, a controller, outer, triggering the use case inner, and then the use case calls back out through the interface it defined, to the presenter, outer, which implements that interface. This way, the actual source code dependency still points inwards. The inner layer only depends on the interface it defined itself. The architecture's integrity is maintained.
That's actually really elegant when you think about it. Solves the problem neatly.
Hmm.
And what about the data itself? What kind of data should be passed across these boundaries?
Uncle Bob really emphasizes keeping the data crossing boundaries as simple as possible. Think basic data structures, sometimes called DTOs, data transfer objects, or just plain arguments in function calls.
Simple data bags, essentially.
Pretty much, the key is to avoid passing complex objects like entities directly, or anything tightly coupled to an outer layer, like, say, database row objects or specific UI models. You don't want your inner layers knowing anything about the data formats used by the outer layers.
Right.
When data needs to cross a boundary, it should always be transformed into a simple neutral format that's convenient for the receiving inner layer.
Keep the data crossing the borders as clean and simple as the architecture itself.
Got it. Okay, let's pivot a bit now to the practical side. That Reddit discussion you mentioned sounds like it offers some interesting views from developers actually using clean architecture or thinking about it. What came out of that?
Yeah, the Reddit thread really highlights the ongoing discussion around clean architecture and its buddy, dependency injection, or DI. Some developers feel that while, yes, these principles can lead to more testable, maintainable code, they can also introduce quite a bit of abstraction and indirection.
Which might feel like overkill for certain kinds of projects.
Yeah.
There's a feeling that sometimes the focus can shift towards just rigidly following the pattern, maybe even if the actual benefits aren't super clear for smaller or less complex apps.
So it's not just about writing technically good code, but making sure you're not adding complexity just for complexity's sake, like following a pattern religiously.
That's a key theme, yeah. Another point raised is about smaller apps, or maybe what some devs call disposable apps, internal tools, short-lived projects, that kind of thing.
Right.
For those, the extensive testability you get from clean architecture, often involving a lot of mocking dependencies, might not be worth the extra upfront effort. The argument is concepts like IOC and DI are still useful for flexible code, but maybe going full clean architecture isn't always the most efficient use of time for every project.
Yeah, I can definitely see that perspective. If you know an app has a limited life or really simple requirements, the overhead of setting up a full clean architecture structure might outweigh the long-term maintainability gains because there isn't much of a long-term.
Exactly. The discussion also touches on practical challenges with larger projects that fully embrace clean architecture, specifically the potential headache of managing multi-module projects.
Ah, like separate projects for domain application infrastructure.
Right. When you strictly separate everything into distinct modules like that,
Yeah.
just configuring the dependencies between them, managing the builds, coordinating changes that can introduce its own layer of complexity and operational burden.
Yeah, I've heard that managing dependencies in big, highly modular setups can become a job in itself sometimes.
Definitely. So there's a pragmatic suggestion that comes up in the thread. Find a middle ground, especially for smaller projects. Instead of rigidly separating into different modules, maybe just organize code by feature within the same module.
Yeah.
Use folders, namespaces, good internal structure to enforce separation without the multi-module hassle.
Okay, like logical separation within a single deployable unit.
Right. Some even argue that for many applications, a well-organized single module with clear internal boundaries is perfectly fine. Multi-module setups might be reserved for specific cases, like sharing code between different platforms, web and mobile maybe, or for really huge teams where physical separation helps.
So the overall vibe from the developer seems to be clean architecture offers powerful principles, absolutely, but you need to apply them thoughtfully, pragmatically. Consider the context, the size, the the goals of your specific project. It's definitely not a one-size-fits-all silver bullet.
Absolutely. It's about understanding the core ideas and then making smart choices about how to best use them to get real value for your situation.
Okay, fantastic. So as we bring this deep dive towards a close, let's quickly recap the main principles of clean architecture we've explored today. What are the absolute key takeaways for everyone listening?
I'd say the fundamental principles are really that separation of concerns, the all-important dependency rule, making sure dependencies point inwards, keeping inner layers independent, and the layered structure that enables all of this.
Right. And the big advantages we talked about are improved maintainability code that's easier to change safely, much better testability, allowing focused tests on core logic, and increased flexibility, making it easier to adapt over time, especially for bigger, longer-lasting projects.
Exactly. You generally end up with a system that's more robust, easier to evolve, and less likely to break in unexpected ways when you need to make changes.
But we also need to balance that against the potential downsides. That initial investment in design and setup, the extra complexity, which can sometimes feel like overkill, and the risk of, over-engineering simpler apps.
Correct. The decision to go with clean architecture, or how strictly to apply it, should really be a deliberate one. It depends on the project's needs, its expected lifespan, its complexity. It's about finding that sweet spot between having a robust architecture and the practical need to get software built and out the door efficiently.
So it really leaves you with a question, doesn't it? Considering the balance between structure and speed in your own projects, where do you see these principles of clean architecture offering the most value? And where might, a more pragmatic, maybe less layered approach be the better call? It definitely encourages you to think about how these ideas connect with your own coding experiences and the environments you work in, including potentially something like the vibe environment, and maybe spurs some further thought and discussion.